Thank you for having me. I'm Misja Heuveling, Senior Principal Solution Architect at Software AG. As you can see, I'm in orange. It's King's Day in the Netherlands, so normally the streets would be completely orange, but I'm offering up a bit of my time to actually present here the service mesh, or how we call it, AppMesh, to manage APIs on top of a service mesh. At Software AG, solution architect, so I focus mainly on our two domains, integration and API, and IoT applications. And for IoT or integration and API, I'm now presenting this story. What I will be presenting, you maybe already have read, is how you can use a service mesh to actually give it context. And for that, we first would like to take a look at what is a service mesh and what is then the app mesh that we have defined, and how can we work together. But first, a little bit of context in this. It's all because technology trends are emerging nowadays. Although I've been in the IT market for over 20 years now, a large amount of it in integration, we do still see a lot of trends coming by and go, of course, but one thing that you keep on seeing is modularity and scale. And that's becoming more and more important, even though in the past companies wanted to have one large ERP system to do everything in. We now see that companies are embracing cloud because of different kinds of reasons. Some embrace cloud for the cost, others for the skill, others for seasonality. But we do see a lot embracing of cloud technologies, and that can be in very different matters. It can be having just a cloud platform, infrastructure as a service, so that you have fastest amount of hardware that you can very easily use and also return if you don't need it anymore. But also more and more adoption of software as a service. And that trend is actually leading to a more splintered IT landscape, whereby data and services are becoming more and more important. It becomes more important to gather your data from different kinds of sources. And that's why, in our opinion, APIs are very important, because we need to bring together the information from your old ERP system, but you also need to bring in the SaaS applications, combine them together. And APIs also bring you the opportunity to expose your existing data to the outside world, to start new business models, or to give an extra kick in your innovation space because you want to connect with your partners or your ecosystem. Sell in different ways, offer information next to products, etc. And that's giving you the challenge that more and more work needs to be done, and that's why agility is so important nowadays. Thereby companies are more and more also giving autonomous teams the tools and capabilities to become agile and to be able to disrupt and change very rapidly. And that's why we see a very big rise of microservices, where the large applications are split up into smaller self-contained units, which are managed by independent teams. And what we also see a lot is personalization. More and more the customer is king. Customer has always been king, but now we are able to give customers much more context by freeing up the data from the systems, knowing more about the customers, and combining all that data into a very personal experience. Well, that's what we see. So in the past, we saw big monolith applications. They were very useful in a way because there was only one system. You would have very much control over how you would manage that application. Everything was in there. But we've seen that also creates challenges. One change to the main big ERP system means everybody is impacted. And that's why we saw the rise of microservices, applications being divided into first macroservices, if you would like to call it like that, split up your one big ERP into resource planning, CRM, customer service, and yeah, have those applications as separate blocks which you manage separately, thereby keeping some of those applications on premise, moving some applications into the cloud, but also rebuilding some applications with maybe low-code application building tools and deploying those in microservice fashion. Those microservices would grow and grow, and you would get more and more microservices. And that also brings its own challenges in its way, because it would bring the challenges of controlling how these microservices would speak to each other. If your microservice landscape becomes this big, how do you know where to find which service and how to connect to it? How to detect failures? What if a microservice is not there? How would you retry? How would you help with central logging? And that's typically where the service mesh comes in. You don't want to code all of these things in your microservices itself. And that's why the microservice actually manages, or the service mesh manages your microservice infrastructure. So here we now see that the microservices start to cooperate with the service mesh. Typically in a service mesh, you would have your microservice, which contains your business logic. Next to your business logic, you deploy, or typically this is automatically done by the microservice platform that you have yourself. It deploys a kind of proxy next to your business logic, which actually hooks your business logic to infrastructure services. Things like service lookup, things like SSL channels, if you would like to secure communication between microservices. But also routing. What if a microservice breaks down? The proxy would automatically reroute to another instance of the microservice that it is aware of. So this gives us a lot of capabilities which we can use to manage our service mesh to our microservices. It gives a lot of context and usefulness in our service mesh. But what we saw is that the service mesh is very much focused on the infrastructure part, and not so much on the application context. So how do I actually, well, for instance, mask sensitive data? The service mesh knows about, can I retrieve data from microservice A or B, but has no knowledge of consumer A or consumer B is using it, and consumer A can see everything, but consumer B can only see a subset of the data due to whatever reason, maybe compliance, GDPR, whatever. So it doesn't solve all our problems. And these are typical problems that we see appearing that are normally solved by an API gateway. But an API gateway in a microservice landscape also doesn't fit very well, because these microservices, they change a lot, they shift a lot. So you're not deploying a huge or a huge API gateway inside each container as a sidecar, as we call it. So an extra piece of logic controlling things like security in the user context, or logging in user context, or personalization, or those kind of things. So do we code it in the service? Of course we don't. So what we did is we actually combined the service mesh with our application context. You might know Software AG, you might not, but what we offer is already one of the leading API management platforms that's giving you the context in terms of an application on top of your API, using intelligent context-based routing of traveling and throttling, authorization, data protection, etc. Combining that with introspection of a service mesh. So being able to see the services which live in the service mesh, so making use of the introspection, etc., and combining that with the application context, giving you best of both worlds. Now, how does this work? This is a typical architecture picture of a service mesh. We typically use Istio, which is one of the big service mesh providers in the space, but it's not the only one. And we do support more with the upcoming version of our API gateway. And what we see is we have our microservices, the logic that you've built in your language of choice. So this can be a C# service, this can be a Java service, this can be a Go service. As you know, you can build anything, containerize it, and deploy it in a microservice landscape in, for instance, Kubernetes. And then what the service mesh does is it has all kinds of services to orchestrate the Envoy proxies. And these Envoy proxies do the communication. What we do is we add an API gateway in this mix that's controlling an additional sidecar, which is our micro gateway, a very lightweight, small runtime, just like an Envoy proxy, which is added into the service as a complete pod container, exposing the service, adding the infrastructure logic, and on top adding the application context logic. Mixer is the component that's controlling the Envoy proxies, so that's telling all those proxies where are my microservices, how can I reach them, how do I do the routing between those microservices. And our API gateway is controlling our micro gateways, telling it which policies to apply on our APIs, and thereby exposing your microservices in a secure and controlled manner, giving you insight on your APIs. So how does that provisioning typically take place? First, we do a service lookup from the API gateway. So we actually introspect the pilot, which is kind of the service catalog for the service mesh, look up which APIs have been published, and then from there, giving us an overview of all the microservices available in the service mesh. We would then configure an API, attach all the metadata to it, so apply policies for authentication, apply policies for logging, apply policies for throttling, performance monitoring, those kind of things, so that we, for instance, can warn our consumers if performance is degrading, and thereby maybe automatically scaling up. Although typically the scaling up is being done by the surface mesh itself. After having applied the API policies, we can then provision the API policies as the micro gateway next to the Envoy proxy in your microservice, and thereby making sure that the communication between microservices is handled. Then finally, I would like to point you out that you can try it yourself as well. We have a couple of resources. First of all of our software, or most of our software, is available in Docker Hub as Docker containers, which you can download and try for free. Next to that, in our GitHub location, we have lots of samples on how to use API gateway, the surface mesh, but also our other technologies. And what I especially would like to point you out to is getting started with the AppMesh. It's a video which you can actually use to go step by step through experimenting with this surface mesh. It helps you setting up a local Docker Kubernetes environment using Docker Desktop for Windows, or Mac OS if you have it. That's also possible. The Kubernetes shipped with Docker Desktop is then used. We deploy Istio on top of it. We deploy a service into it, and we will then expose the service and apply policies on it and manage it in that way. So also, feel free to watch the video on how it really works, apart from this slideware introduction. You can use the software from Docker Hub to do that, and additional samples from the Software AG GitHub location. That would leave us now to the question and answer.
Yes.
Yeah.
Thanks for the great presentation. At the moment, I do not yet see any chat messages from people.
I hope this was then a very a clear presentation, I guess.
There's the first question. What would you handle in the micro gateway that's not suited in the mesh?
Yeah. What we typically handle in the micro gateway is the application context. So if we would go back to the slide about those surface meshes, it's everything that having application context. The surface mesh typically takes care of the microservice itself as a whole. But with APIs, we can be much more fine-grained. APIs have, for instance, different methods. And for those different methods, you can have different policies. So as you might know, there's the authentication scheme OAuth 2, in which you can separate your API in scopes, thereby, for instance, giving a read scope and a write scope, and giving different users different rights to those scopes on those APIs. That would be something that you can deploy in the micro gateway, so that different user groups can only read the APIs, whereas other user groups can also invoke the right services on those API. I hope that is an example that makes the question clear, answers the question.
And then another question is, a suggestion which service mesh to use for somebody new to Kubernetes?
Yeah, well, I think Istio, it's the widest being adopted by many companies at the moment. There's great tutorials on the Istio website which actually help you get started on deploying Istio. With a few commands you have it deployed in your local Minikube environment. It's very easy, and you already have a very good overview of how it can work, how you can do your load balancing, your A/B testing using a service mesh, for